So in the last class, we have seen various asymptotic notations in algorithms concept. So big O represents the worst case time complexity, and big omega represents the best case time complexity, and big theta represents the average case time complexity. So we have seen those different kinds of time complexities in asymptotic notations. So now in this we will see how to analyze the time complexity for each program. So in algorithms, there are two types of uh, programs that we can able to calculate the time complexity. So in algorithms, there are two types. First one is iterative and the second one is recursive. So in the iterative, we will define like this. We'll use this a function, and after that we will give for I equal to 1 to n maximum of a comma b. Maximum of a comma b. So this is the iteration which is running from 1 to n. So this is the example of iterative algorithm. So next one, recursive algorithm. See here a of n. Next, if here we are giving the condition, next we are calling the a of n by 2. It means here we are calling the function again and again. So that's why it is called recursive. So yeah, we are suppose why we are using complexities means. So we are having these two types of algorithms, and which we can able to measure the time complexities for this iterative and recursive. So other than that, if we are having any other programs other than iterative and recursive, it will give that constant time complexity. It means within our constant time we can able to measure the time complexity. It means for that programs it will be having the time complexity order of 1. So other than iterative and recursive programs, um, the time complexity for other programs is order of n. So for the iterative programs and recursive programs, they are having the time complexities um, based on the based on the conditions and based on the iterative programs. So now we will see an example. So now we will see one example for iterative program. So here see a int I for I equal to 1 to n printf Ravi. So we are having one variable here. I am iterating from 1 to n. It means how many times I am iterating from 1 to n. It means I am iterating 1 to n times. So whenever we are running this program 1 to n times, and also we are asking to print up Ravi. So whenever you print up Ravi, how many times it will print means we are running this program, we are iterating this program from 1 to n. So it will print the Ravi n times. So overall time complexity for this program is order of n. So like this, we have to measure the time complexity for each iterative program. Suppose R A. Next, I am having two variables. Here I am having only I. Here I am having two variables. So I and j. And also here I am having two loops. Here I am having only one loop, but here I am having two loops. So I equal to 1 to n and for j equal to 1 to n. So print of RAM. So first loop, how many times it will run? From 1 to n. It means it will run up to n times. So the time complexity for that is order of n. So it runs for order of n times. Next loop, for j equal to 1 to n. It means up to n times it will run. So order of n and order of n. So overall it will print it will run the program order of n square. So the time complexity for this program is order of n square. Here we are having the two for loops, and it is running the each loop order of n times. So this order of n time and the order of n times making this loop order of n square times. So the time complexity for this program is order of n square. So next example, see the next example. So a and open braces. Next, I equal to 1. So for I equal to 1, I square is less than or equal to n, I plus plus. Printf Ravi. So here I square is less than or equal to n. So here I can able to write this I is less than or equal to root of n times. So this Ravi will print order of root n times. So the time complexity for this program is order of root n. And also here the specialty of this program is the best case, average case, and worst case. All are all comes and all will take only order of root n. So it means we can able to write order of big O of root n, big theta of root n, and also a big omega of root n, because it is taking best case, average case, and worst case as order of root n times. So this is the third example. Next one, sir. So this is yet 1991 question. So here see, A, here I am having the variables I equal to 1 and S equal to 1. So while S less than or equal to M. So here given the condition next I plus plus, next S equal to S plus I. Printf Ravi. Now we will see how the program will run, and also we will see the time complexity for this program. So first one for I equal to 1. So here I is given as 1. S is less than or equal to, and also S equal to n. S less than or equal to n. Yes, the condition is true. So whenever the condition true, I plus plus. So the value of I will become true. So S equal to S plus I. So what is the value of S? 1. 1 plus. What is the value of 2? What is the value of I? 2. So whenever the I value is 1, whenever the I value is 2, the S value is 3. Next one, whenever the I value is 3, now increment the value of I as 3. 3. Next, S equal to S plus I. So what is the value of S? S is 3. 3 plus, so what is the value of I? 3. 6. So whenever the I value is 3, the S value becomes 6. Next increment the I value. So 3 plus 1, 4. So what is the S value? 6. So 6 plus 4 is 10. So whenever the I value is 4, the S value is 10. Whenever the I value is 5, the S value is 15, and so on. So here see, whenever you add those whenever you add those sum of two numbers, we are getting the S value. So like that, whenever you are adding the sum of first n natural numbers, we are getting the value S. So as we know that for how many times this I will continue up to k times. So at what time the condition will become false? So whenever the sum of the n natural numbers is greater than n. So here we see up to s less than or equal to n. So this s value will run from 1 to n. So the first sum of two natural numbers gives the value of so yes. So the sum of first natural numbers formula is k into k plus 1 by 2. So we have to take the condition, we have to simplify it. So here they are given up to whenever the s value is greater than n, it will become the condition becomes the first. So we have to take that condition in order to get the solve the question. So here k into k plus 1 by 2, because sum of n natural numbers formula is k into k plus 1 by 2 is greater than n. So now k square plus k by 2 is greater than n. So k square plus k is greater than 2n. Now, now what we have to do is uh, k square equal to n, k equal to order of root n. It means the program is running up to order of root n times. So the Ravi will print um, in order of root n times. So the time complexity of the program is order of root n. So whenever you solve this k square plus k by 2 is greater than n, you will get the value k value as order of root n. So we will print in order of root n times. So the time complexity for this program is order of root n. So next one see. So int I j k n. So for I equal to 1 and j I less than or equal to 1, I plus plus. Next one, for j equal to 1, j is less than or equal to y and j plus plus. And for k equal to 1, k less than or equal to 100, k plus plus. And printf Ravi. Here see we are having different loops. So here j value depends on I. So now what we will do is we have to take for each. So whenever one loop is depending on the another loop, we have to unroll it. Means we have to take each value and you have to see what will happen for each value. So for I equal to 1. So whenever the I value equal to 1, so next take the j value also 1, j equal to 1. So for this, we have to go through this loop and this k value depending on this. So k is less than or equal to 1. It means k into it means I 1 into 100 100 times. So k will print 100 times whenever I equal to 1 and j equal to 1. Next, whenever I equal to 2 and j equal to 2, the k value becomes the k equal to 2 into 100, because here we are running this loop two times. So for each time we are multiplying this with 100 times. So here we are running the loop two times. So the k value becomes 2 into 100. Next one, whenever I equal to 3, j also will become 3 times. So we will run this loop 3 times. So whenever we run this loop 3 times, here we multiply this k value with 3 into 100 times, because for each time it is running 100 times. So for 3 times, we are running this program 3 into 100 times. So for like that, whenever you take the I value 4 and j value 4, the k value becomes 4 into 100, I value equal to 5 and j value equal to 5. K value become 5 into 100. Like that, you take I equal to n and j equal to 9. K will take, k value will run up to n into 100 times. So like that, whenever you take 100, 200, 100 times, 2 into 100 times, 3 into 100 times, 4 into 100 times, and n into 100 times, you take the 100 common and 1 plus 2 plus 3 plus and so on n. So 100 into. So 1 plus 2 plus 3 n plus and so on will become the sum of n natural numbers. So what is the value of sum of n natural numbers? N into n plus n by 2. So n square plus n by 2. So take the tightest bond. So it will become the order of n square. So within order of n square, this loop will complete and it will print the array. So the time complexity for this program is order of n square. So this is the fourth example. Now see the another example. Print I, j, k, n. Next, for I equal to 1 and I less than or equal to n, I plus plus n times. Next, it means this loop run for n times. Next one, for j equal to 1 and j is less than or equal to I square, j plus plus. And also for k equal to 1, k less than or equal to n by 2 and k plus plus. Here see the value of j is depending on the I value. So whenever the is depending on the other loop, just whenever you see the dependency between these two loops, just you need to unroll it. It means you have to take the each value and we have to see what will happen for each value. So you have to calculate for each value from this loop. So whenever I equal to 1, j is less than or equal to I square means 1 square means 1. So I equal to 1, j equal to 1, k equal to n by 2 into how many times it is running? 1 time. So n by 2 into 1, because this k is depending on this. So whenever we are unrolling it, we have to multiply to each time. So this n by 2 into 1. Next one, whenever I equal to 2, j equal to I square. So I equal to 2, 2 square means 4. J will run up to 4 times. Now k equal to n by 2 into how many times this loop is running? 4. N by 2 into 4. Like that, I equal to 3. J will run up to 9 times. And k value becomes n by 2 into 9 and so on like that. I equal to n, j equal to. So whenever you run this up to n times and j value will become n square times and k value will become n by 2 into how many times this loop is running whenever I take the value I in the. So it will run up to n square times. So now you add all those things n by 2 into 1 plus n by 2 into 4 plus n by 2 into 9 plus and so on plus n by 2 into 9 square. So take n by 2 as common and uh, 1 plus 4 plus 9 plus and so on n square. Now n by 2. So this is the sum of all square natural numbers. So what is the formula for the sum of square natural numbers means n into n plus 1 into 2n plus 1 by 6. So multiply this and n into n into 2n, 2n cube. So 2n cube into n, 2n power 4 by 12. So here the tightest upper bound is order of 2 power n power 4. So take the tightest bound and it will run the loop up to order of n power 4 and it will print this value within order of n power 4 times. So the time complexity for this program is order of n power 4. So this is so like this we can able to measure the time complexity for each program and we can able to define the time complexity for iterative programs. So if you want to measure the time complexity for iterative programs, you need to go through this and you have to measure the time complexity for iterative programs. So these are the examples of that iterative programs and this is how we measure the time complexity for each iterative program.